Good morning and good afternoon, and welcome to this conversation today with Flash Networks. I'm talking here today with Ofer Gottfried, the CTO at Flash Networks, and this conversation is part of a report on core optimization and traffic management from Sensafili in collaboration with RCR Wireless. Ofer, thanks for being with us today.
Thank you.
So I would like to ask you, what is the Flash Network does in this area, and what is it you work on specifically these days?
Yes, Flash Network is doing for a while, helping operators to do less and more with less. So enable the operator to utilize their assets and infrastructure, radio infrastructure, to utilize them to serve more users and with a better quality.
And what is it you do specifically? Is there any area that you're specifically focusing on these days?
So today we are focusing more on a radio data spectral efficiency. What we are able to do is from the core to streamline the data for better utilization of the radio, and by that enable the radio to serve more users and more radio connections and more throughput to the audience of the operator.
Yeah, so what is that has been changing? This is an area where there has been a lot of changes over the last few years. What is that you see when you talk to operators? What are the major pain points that you are trying to address?
So today with more and more radio load from both throughput and higher video resolution and more HTTPS video, from one end, and from the other end, more connections and more radio connectivity from Internet of Things or Internet of Everything, and connected cars and more smartphone and application and devices. They are loading the radio not just from throughput or not from the load perspective of the user consumption, but also from radio connectivity and radio connection. And those are the things that we are today able to optimize and to give better service for the users on the radio, with even serving up to 35% more users on the same radio infrastructure.
Yeah, so you mentioned radio and Internet of Things. Is it just a part of having more traffic, or is there more to it? Because if there is more traffic, you just need to build more capacity, right? But I don't think it's that simple.
Yes, it's not that simple, and it is costly. So the KPIs or the main bottlenecks of the radio is not just throughput. Sometimes there is enough bandwidth or there's enough throughput on the radio, but as there is more and more connections on the radio and more users or devices or things that are going on and off from the network and creating also signaling, radio signaling and core signaling, in order to get service, those are sometimes the inputs to the radio that are a bottleneck to serve more throughput or to serve more users on the same infrastructure. So in order to get more from your radio network, you need a solution that optimize or handle not only the throughput with traditional optimization or new optimization of HTTPS video, but also to handle the connectivity and radio connection optimization, and by that also handling the signaling load, which is associated with every device or element that is requesting for radio connection or radio service and going down from radio services. And we are able to optimize both those angles in the radio in order to get this spectral efficiency or spectral utilization much better than without our solution.
So this is interesting, because what you're working on is to improve the network utilization, the resource utilization in the RAN, but you're not necessarily just working in the RAN, you're working end to end. So you're optimizing the data flow that gets to the RAN before it gets to the RAN, right? But how do you put the two together? Because eventually everything has to go through the RAN.
Yes, and you're absolutely correct. By us looking at the data and understanding the data, and we're doing it for the last 19 years, we have a lot of experience in working and managing mobile data. We are able to find those scenarios which are not optimized or not designed for the mobile radio. For example, if a server wants to send a control packet to the radio or to the device, he's just sending it. He doesn't care whether the device now is in idle state in the radio or connect state in the radio. And with our experience, we are able to detect and to know what is the state of the device, and then to optimize or to better utilize the state of the device with the traffic from the internet or from the servers to reduce the amount of state changes of the users from idle to connect and from connect to idle. And by that, reduce the load on the radio from the core.
That is this is very interesting, because you can sort of prevent congestion from happening in the first place. Now, when you have a HATNet type of environment where you have multiple elements that cover the same area, how is that apply?
So it's applied really in the same manner. Whatever a radio access is now serving a user, we are able to see and to monitor all this user traffic. And by seeing or monitoring and streamlining all this user traffic from the TCP layer to higher layers, we are able to prevent this unnecessary state changes or unnecessary load on any type of radio, regardless of the type of radio. And by that, you need less radio to serve more users.
Mm-hmm. Very good. So you mentioned multiple things that you're doing at the same time, sort of seems like in parallel. So maybe you should go through them more carefully, each one by one. So the first one, you're working on the data spectral efficiency. And how does it relate to the spectrum efficiency in the RAN?
So basically, we have 4 main features that we are applying today. The first one is the radio connection and signaling optimization, which have also some subcategories. We have the ability to detect some TCP control messages that are being sent from the server to the device or to the thing when the device or the element is in idle state. And because this is a control message, it is not necessary currently for the application to behave as needed. We can queue this message and send it later on when the device is in a connect state. So by that, we can save the connect and disconnect state and the associated signaling with it. And by that, we can save a lot of radio connections. The second one is also to synchronize some keep alive or repetitive data. There are few servers that are connected to the same device or to the same device that are running few applications, and each one of them has some keep alive information or keep alive data that is coming every few minutes. We can synchronize them to the same phase of the 1 minute, and by that also save change states in the radio. So then again, saving radio connections. And we have multiple scenarios in this area. So this is the first main feature in our radio spectral efficiency. The second layer is about TCP acceleration. We know also that TCP was not designed for mobile and was not designed for the dynamic mobile environment. We have, for the last 19 years, improving our TCP acceleration feature that enabled the cell site to transmit throughput, higher throughput than without our accelerations. So we can gain 10% in cell throughput increase without TCP acceleration, while improving also the quality for the end user. The third element in our design is about congestion prevention from throughput perspective. We are able to detect congestion situation when the user is getting less than X throughput, X megabits per second, and it's configurable, of course. And by that, when we detect it, we can control the load. For example, limit the maximum resolution that the YouTube will now load the network. And by that, we enable the operator to control its load and not to give the content vendors the ability to overload its network in this overload condition that we can detect them autonomously. So both from throughput perspective and from radio connection perspective, we're able to reduce the load and prevent congestion from the radio.
Now that's quite interesting, because that's as you move to more real time, it's all very good because you can manage the network load and traffic load depending on the conditions. But a lot of the time you want to prevent congestion from happening. So you need to start acting before. So how do you look at the network? What are the key, how soon before congestion happens? Because there is a lot of spikiness in the data. So the fact that there is a high utilization at this very moment doesn't necessarily mean that it's going to be protracted. How do you decide where you're about to get into trouble with congestion?
So we have a few layers of detection. One of them is user congestion. So we are able to identify the situation when the user is getting less than, for example, 2 megabits per second from the network, from the radio. And this could be congestion level 1, so a low congestion level. And with this congestion level, you can start optimizing or start controlling the load in a small level, or reducing YouTube to 720p, for example, and not allowing YouTube 4K. And once the user will get from the network only 1 megabit per second, you can squeeze more or load more, control more the load from YouTube. For example, to limit it to 360p or 480p, still good quality, but you allow your network to serve more users with more bandwidth while controlling the load from others, and only when you need it, only when you detect this congestion. And this is the congestion on a user level. What we're able also to do is to get the cell ID and get the congestion per user that are connected to the same cell. And by that, we can prevent congestion while detecting that 10% of the user are getting congestion. Let's start do some proactive controlling the load. And by this algorithm, we're able to prevent congestion from the cell.
So in this case, you use geolocation in combination with the analysis of congestion, right?
Yes, and this is something that we can get from various resources. Mm-hmm. Either from Radius or GX, or we have some proprietary implementations that we are doing with some partners of ours, radio partners, that can send this data on the TCP header. So it's very real time without any need for loading the other elements or other areas in the core.
Right. So you can easily integrate this information from multiple sources, which is critical because you need that information, but not all operators have the same setup.
Yeah. So because of that, also we have the ability both to enable it just by user congestion detection, which we have autonomously and we don't need any external information, or we can enhance it with some external information about the cell ID or geolocation.
Mm-hmm. So basically your solution works regardless of what is the RAN vendor, in the sense that you are above from it and you can get inputs from them, but you're not dependent on it.
Exactly.
That's a crucial requirement. Now, we talked mostly about streaming video, but there is also an emerging sort of conversational video where it's the quality requirements or the expectations from the end users are kind of different. Is there anything different that operators would do to manage conversational video, like ViLTE or other type of video experiences? Which is also, by the way, symmetrical. It's not just downstream.
Yes, so we have a few solutions for that. One of them is also we do also acceleration for uploads, which is also something that is in these videos very, very crucial. And sometimes the upload is the bottleneck, especially in those bidirectional conversation. But above that, most of those services today also are getting either into VoLTE or other guaranteed quality of experience and getting some high marks on the radio from quality of experience. So this is something that the operator has the ability to give them these special resources that they need in order to get the right quality. And above that, we're able also to control the load on those services once they are also ABR videos, because they also have the ability to go up and down in the bit rate that they are consuming based on the network condition. And we can limit or mimic a network condition that will allow them, or that will require them to go down a little bit in the bit rate in order not to overload the radio, as the radio resources are needed also for other users.
Mm-hmm. Yeah, so you can basically do that on a dynamic basis based on the network conditions, policy, and putting all this information together, right?
Exactly. We can get also user plan or user ID, and to get for different users to apply different optimization technique or different features in real time.
Yeah, and that's quite important. When you talk to operators, what do you see? You know, all the time you're working on different fronts. What is it? It's really keeping them awake at night these days. What are the major concerns that you're trying to address that you can hear from them?
So today we can I think we can summarize it in the main problem of the network planners is about radio connections and radio connectivity. It is if a few years ago, or last year or 2 years ago, it was about the throughput and about the load of videos. Today it's more and more radio connections and how to maximize the network with radio connection. This is also the main benefit of our latest solution about the radio spectral efficiency. And we already are doing 4 multiple trials on this a new solution that we just launched late last year. And one of the anecdotes is that I met one of the operator, VP Finance, just as a courtesy meeting, and explained to him what we are doing and what is our solution. And even the VP Finance knew about the radio connection problem in its network when he's not a technical guy. Mm-hmm. So this is something definitely that is a problem. And in every operator, it's a problem in the different phase of its life. Sometimes it's an operator that just launched LTE, but still a major of his customers are running on 3G. So he needs the solution to better utilize its current 3G assets and not to upgrade them, to utilize our solution in order to get more users on its 3G network until his 4G network will be more loaded and there will be more users moving to LTE. There are other users that are far away in their LTE launch, and the LTE is already loaded with more and more connections and more users, and there is a need both for acceleration and data control and congestion prevention, and of course radio and signaling optimization for the radio itself.
Yeah, and as you say, I guess the different operators have very different needs depending on what their infrastructure is, what their subscribers are doing, what their policies. So I guess you need to be flexible in offering a solution that meets the requirements of all this different type of environments, right?
Yes, definitely, and we still have also our old and very powerful legacy optimization from transcoding, translating days, caching, and header enrichment and things like that you need. In few areas in the world, the traffic is different. There are areas that most of the video now is HTTPS and ABR videos, and there are areas that are still progressive download and caching is needed, and progressive and even buffer tuning or pacing is needed. And we have there also buffer tuning specifically for radio utilization. We call it burst mode buffer tuning, because also there you need to not to overload the radio while doing some pacing there. We have a patent on it also. So all those techniques are still with us and are still working in few areas of the world. And we have the ability to configure the system or to manage the system based on the requirements of the operator for its unique condition and unique requirements.
If you were to say, what is the thing that the feature or the Flash networks you contribute that is special, that sets you apart from everybody else?
So we have two main differentiator or big differentiator. One of them is a differentiator for a long time is our TCP acceleration. This is the best TCP acceleration out there. It's our own TCP control algorithm, congestion management algorithm, and this is something that we are improving, continue improving and investing all the time. The second one is the radio connection and signaling optimization, and this is something unique, doing it from the core without the need or anything downloaded to the device. It's without any need for any cooperation with any content vendor or any device manufacturer. And to optimize from the core, the radio connection and the signaling, this is something very unique that we are very proud to launch in the market.
Now, let me ask you, there is a lot of talk of virtualization, not just talk, the operators are actually deploying it. How is that going to change your solution? And also, what about mobile edge computing as well? Are those two things that will change the way you approach the problems you're trying to solve?
So mobile edge computing is something that is we are also working on it. This is something definitely that we are monitoring. Today, it's much more easier to launch our solution on the core or even outside of the network. We have also the ability to have the solution on the cloud for the operator. But once the technology will evolve and is evolving to more virtualized and easier to deploy applications on the radio side, on the edge, we will be able to utilize it and to even have a better granularity of the real time of the optimization on demand and only when it's needed, because we'll get some more inputs also from the radio, and this will only enhance our solution that we have today.
Okay. In closing, what is that you see happening in the future over the next few years? What is that you're working on? What is that the industry will have to deal with?
So definitely the Internet of Everything is now booming, and one of the predictions that every person will have 15 connected devices generating from himself. So this will be definitely something that will change the mobile environment. This with the continuous demand for more throughput and more quality for the user. In the CES, we saw the 8K TV. So once this 8K streaming will be on the mobile, this will definitely demand a huge data and huge capacity increase in the mobile. So continuous improvement in best utilization of the radio infrastructure, which will become more and more scarce and more expensive in order to load all this demand. This is something that we'll definitely see in our future, in our roadmap. There is two other areas that we are also looking at. When there is more and more HTTPS traffic, there is also more and more potential risk in this HTTPS traffic that is coming maybe from content that is not safe. So with our ability to sit in the middle of the network and to give the users and by the operators a secure pipe or a smart secure pipe, even on HTTPS, but also by controlling the traffic and monitoring the traffic in this HTTPS, this is also something that we believe will be needed both for enterprises and consumers as a trusted pipe from the operator to gain more control and more security for the users.
Yeah, I guess, yes, you're absolutely right. Security is going to be an issue along with IoT, because it's not just traffic, it's not just volume, it's more than that. It's what goes through the pipe and who does it go to. Ofer, well, thanks a lot for talking to us and sharing your insights today. This interview was part of a report on core optimization and traffic management from Sensafidi Consulting and in collaboration with RCR Wireless News. Ofer, thanks for being with us today.
Thank you very much for the time.
And thank you all for attending.